sun influences everything we experience on Earth. Earth is so perfectly positioned to experience this.
Totality hits.
This amazing phenomenon that is so rare throughout the universe.
This is a great time to learn more about our own star and how it affects our daily lives.
Instant chills.
I burst into tears.
There's no other feeling like it. It's insane.
Everybody should be watching.
Hello and welcome to NASA's live coverage of the 2026 total solar eclipse. We're at NASA's Goddard Space Flight Center, and over the next hour or so, we'll be tracking the eclipse as it races across the North Atlantic and Europe. A total solar eclipse occurs when the moon moves between the sun and Earth and completely blocks the face of the sun, casting a temporary shadow on Earth. People located within the moon's shadow, also known as the path of totality, will experience a total solar eclipse. The sky will darken briefly as if it were dawn or dusk. So weather permitting, people in the path of totality will see the corona, the sun's outer atmosphere, which is normally hidden by the bright face of the sun. Today's total solar eclipse will sweep across Greenland, Iceland, northern Russia, Spain, and a small corner of Portugal. Many other areas in the Northern Hemisphere are already or will soon experience a partial solar eclipse, including much of Canada and parts of the northern US. And for many along the western part of the eclipse path, such as mainland Europe and Africa, the eclipse will occur early evening, creating a rare opportunity to see a sunset eclipse. Over the next couple of hours, we'll be bringing you live feeds from telescopes across Europe and hopefully views of totality in Iceland and Spain. Thank you so much to our partners, Time and Date, Southern Illinois University, and Exploratorium for those views. During today's show, we'll be joined by experts to learn why celestial events like these ones are important to study, document, and experience. And I have an important reminder on that note. When watching a partial solar eclipse, you must always use the right protection. You can use safe solar viewing glasses, like these ones called Eclipse glasses, or a safe handheld solar viewer like this, or you can use indirect viewing methods as well. Regular sunglasses, no matter how dark, will not work and are not safe for viewing the sun. So be sure to stay safe. Now, let's head over to my colleague Ernie Wright, who can tell us more about where the action is happening today.
Thanks, Joy. I'm standing in front of the map that I made for the eclipse that we're going to experience today. We're looking down at the North Pole here, and the red stripe is the path of totality. Those are the locations that will experience totality today. As we animate this, you can also see the much broader penumbra shadow. That's where the partial eclipse occurs. But here comes the umbra shadow. That's where totality is happening, inside that little oval. It passes over the east coast of Greenland, the west coast of Iceland, and across northern Spain, where, as Joy said, they'll experience an eclipse within an hour of sunset, so they should have lots of opportunities for really beautiful photographs. And then as the eclipse progresses and that umbra disappears, West Africa will also get an opportunity to see a partial eclipse as that penumbra shadow sort of slides off the edge of the Earth here. Now, as we zoom up and look at Iceland and Spain, Reykjavik is here in that southwest corner of Iceland. We're kind of crossing our fingers for them because it's a little bit cloudy there right now. That umbra shadow is traveling over 2,000 miles an hour as it passes through the path and crosses the North Atlantic. And then it runs into Spain here, where we expect more than 15 million people will be watching this eclipse. Some of them on the beach in Mallorca right before sunset, so they should get some really beautiful photographs over the mountains to the west. Now, the situation in the US is going to look like this. That yellow line is the southern limit of the partial eclipse. So folks south of that line, you're not going to see an eclipse today. But if you're north and east of that line, you may already be starting to see the partial eclipse. It takes 2.5 hours for that partial shadow to pass all the way across the United States. So it's not like totality. You don't have to run out there at the exact moment. Some places will have a partial eclipse that lasts for almost 2.5 hours. Others maybe just an hour. So this is the situation right now. Montana, your eclipse is over. The shadow is passing out of North Dakota, but Minnesota, Wisconsin, Michigan, you're in it. The Northeast is also in it. And for folks in the Mid-Atlantic, you will be in it soon enough. Now, before you run outside to look at your eclipse that's happening right now, we want to show you a short video about how to observe this eclipse safely.
If you'd like to find and explore the animated eclipse maps yourself, like the ones Ernie was referencing, safety instructions, and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. We have Dr. Kelly Corrick, who is one of NASA's heliophysicists, who studies the sun and its effects across the solar system.
When we have that eclipse, so that 5 degrees off ends up not having eclipse every new moon.
Okay, and so today's eclipse will travel across Europe for the first time since 1999. Yeah. Can you tell me, why does that region not experience eclipses as often, and what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that A, it's near sunset. It's also the fact that Europe doesn't get as many, just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that we just don't, it just doesn't go over land. Plus with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Oh, fantastic. And I know Europe is going to have another eclipse happening in 2027, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds, so that's a very long one, great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so?
Yes.
So why is it that NASA continues to study solar eclipses?
Because every eclipse is a little bit different. The sun changes as it rotates or changes its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time.
Fantastic. Thank you so much, Kelly.
Thank you, Jill.
So throughout today's coverage, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions today. You can Instagram or tag @NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescope views we have in Iceland and Spain, respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time, or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, for totality there at 2:28 p.m. Eastern Time, or 8:28 p.m. local time. And the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona, where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the science team live from Iceland very shortly. Before we do that, let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try and stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun, and that allows the scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at, it's dark, but everywhere you see it's twilight, and the temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Amir Caspi, who is chatting with us live from Keflavik Airport in Iceland. Hi, Amir. Thank you so much for joining us today.
Hi, Joy. It's a pleasure.
So firstly, how are you feeling right now? And So firstly,
on the moon, so they're able to see the full extent of that corona as well as the zodiacal light in the solar system.
And how long was the eclipse up there?
It's about 53 minutes long, so they got a much longer chance to look at that eclipse.
Wow, what an opportunity. What was the day like for you in the SUR?
It was a very exciting day. This was not something that we really knew exactly how it would be. And so we had just had a beautiful lunar flyby of the illuminated portions of the moon, and then we turned to watch this eclipse. And the descriptions that we heard coming down saying that they were, you know, this is sci-fi, and they couldn't even imagine, and this glow, we didn't see that in our coverage, but once those images started coming down that night, it was mind-blowing to see exactly what they're describing, and I wish I was there myself.
Same. Well, that's incredible. So Artemis 2 has just launched, and so we have Artemis 3 to look forward to. Can you tell me how you're preparing for that mission?
Yeah, so Artemis 3 is a different type of mission. We're not going to be going to the moon. We're actually going to be working in Earth orbit. And so this will give us an opportunity to test our human landing systems, which will be the spacecraft that we take down to the surface of the moon. And so we'll work to hopefully dock with one or both of the human landing systems. But we're also going to have an opportunity to do a lot of science at Earth, because this will be a new, unique viewing orientation as well.
Wow, what an exciting few milestones to look forward to. Well, Marie, thank you so much for joining us today.
Thank you so much for having me.
So if you've just joined us, take a look at these maps that we're showing you right now that's showing the path of the moon's shadow. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. And over in Spain, you can see that we have about 45 minutes left until totality reaches them. So these are views from Villabado in Spain that we're seeing right now. And if we switch back to the map, you'll see that the moon's shadow actually looks pretty slow as it's traveling across down towards Spain, but it's actually traveling at over 2,000 miles per hour. These maps were made by my colleague Ernie Wright. He used various NASA satellite data to create super accurate maps for us. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. So now let's welcome back NASA heliophysicist Dr. Kelly Korrick. Kelly, how are you feeling about today's eclipse?
I'm excited for everyone, and I know those clouds are a little worrying in Iceland. That's one of the reasons we had the plane, but also joyful to see the balloons that are going to be launched, as well as seeing it in Spain. So really excited.
Yes, and I'm sure the NASA pilots must be excited as well in the plane.
Yes, exactly. It's a great view. It really is a great view from that.
So here we're seeing a live view from the WB-57 aircraft sensor right now. They're moments away from seeing the moon's shadow hit Earth and also chasing the eclipse. And we haven't actually seen the view of the corona yet from the nose, but they will be capturing images once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness a partial solar eclipse. There'll be many, many people here that will be able to experience this amazing celestial event. So let's see how many. We're about 6 minutes away from totality in Iceland. Yeah. What do we expect to see right before totality?
Right, so right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you've blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world, because right now they're on almost 24 hours of sun. So they are going to be a little shocked by this. And so you'll be experiencing a lot of different things, even if you don't get to see the beautiful corona.
Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing clouds, but can you tell me, how does the climate shift when an eclipse happens? Because I've heard that the weather can change drastically.
Definitely. So from personal experience, in 2017, I was in South Carolina and there were thunderstorms. And during totality, it parted just around the sun and was able to actually fully enjoy the eclipse and see my first total, that was my first total solar eclipse. So there is hope that the clouds are influenced by that change in day-night, that eclipse that's coming through. So we're hoping that some of the winds and some of that changes could change things for Iceland.
Okay. So we're seeing right now on screen a live telescope view from Spain, and that's because the telescope views in Iceland are obscured by clouds. But as Kelly mentioned, I'm hoping that the clouds will part and the weather will change for them. Anything can happen at this point, right?
Right, anything can happen. And also, we'll talk about it a little later, but the balloon experiments, they are testing the atmosphere. The atmosphere of the Earth is still being affected, even if there is cloud cover, and that helps us with predicting weather models. So it's not just about the coronal science, which is something that I'm very passionate about, but it is also about understanding our planet and how it interacts with the sun and the light that we're getting from it. And you see, oh, we're starting to see something in the WB57. It's getting very close. They were zooming in there, so that's
okay. Oh, wow. Okay, so everyone who's watching right now, the right-hand box, you will see the live views from the WB57 aircraft. That's where the NASA pilots are chasing the eclipse from the skies. So Kelly, can you tell me what are the benefits of observing the eclipse from up there?
From observing up there at 50,000 feet, wow, okay, so I'm looking at these are great. 50,000 feet, you're able to get above all the clouds. So they're above all the clouds, and we're able to, again, allow it to overtake us, so they get a few more seconds of totality. You saw that beautiful pink filament on the sun. That is something that Amir talked about, is that filament, that material that comes off the sun that can actually create space weather and affect our power grids here on Earth. It can affect our GPS, so if you ever use your maps to get anywhere, that's something that we need to understand and be able to predict. It also affects our astronauts, our dear astronauts, so making sure that they're okay. So those things are really important to study, and one of the reasons why we have the WB57. It's a little hard to see, but in the words on the right-hand side, you see that pink filament now on the WB57 feed, which is on the right-hand side. And so you can see it in the NVIS area, now kind of right in the center. You're seeing that prominence, and so this is amazing data. And it might not look as crisp as we're used to. You know, we're used to 4K down here, but this is really data a scientist can love, because this is telling us very specifically about part of the data. So it's like taking only a little part of the TV stream in and really getting the information about the iron or the oxygen or the specific composition of what that's made of. And if we know what it's made of, we can do more science with it.
So we're about like a minute and a half away from totality in Iceland. And so we have a minute and a half for the clouds to part. So the sun view that you're seeing here, that is not of Iceland, but that is of the partial eclipse in Spain. Iceland is still being covered with clouds, but totality will hit them in about just a minute or so. And luckily, our airplane, the WB57 aircraft, they're going to be getting clear views of the eclipse from the skies. So we're going to be seeing what the camera on the nose of the plane will be seeing in roughly 1 minute, which is so exciting for them.
So exciting, yes, definitely. And you are starting to see some of the what would be a diamond ring effect. So those little pink things that you're seeing, this is happens when light passes through the valleys of the moon. So you don't have a perfect circle in the moon. It has those craters, and there's that diamond ring effect.
Oh, wow.
So yeah, so just absolutely beautiful. And that's when you still should have your glasses on. And when that ends, that's when we're able to do it. And I want to comment, this is an experiment, right? And so this is part of the reason why we're seeing kind of the arrows or the crosshairs go in and out. We are real time. This is real time live. How science happens is that we are trying to make sure to make adjustments and make sure we're getting an image.
Wow. Yeah. So we are 7 seconds down to totality in Iceland. This is really exciting. We're getting a shot of the ballooning experiment as well. This is the nationwide Eclipse ballooning project. They've been launching balloons for the past 24 hours leading up to this eclipse, which is so exciting. And I can see that they're getting really excited as well, despite the clouds, because they can actually still collect data even though they can't see the eclipse. Is that right?
Exactly. They can still collect data. They are still experiencing a little bit of that darkness. It's obviously darker. See, it's definitely darker, even though you can't see the corona itself. And a little bit looks like sunset around the 360 degrees. And hopefully we'll see this in Spain, where it'll be very vivid imagery there.
So it looks like totality has hit Iceland, which is so exciting. You can see that the ballooning team is engulfed by darkness here. So that is so exciting. I can see them smiling. Oh my goodness. So why do we see a 360-degree sunset during an eclipse?
Because there is light on either side. It's just simply blocking out in that specific shadow. So it's like the sun has gone down just in that one location, but the rest of the earth is still illuminated. So you still have, oh wow, that is That is images of the